So the problem asks us to, it says find the exact value of sine of u plus v given that sine of just u is 3/5 and cosine of just v is negative 24/25. It says both the angles u and v are in quadrant 2. So if I come over to my document camera, let me stop sharing. If I come over to my document camera, you notice that this is my goal, and then this is the information they gave me, and they told me that both of them were in quadrant 2. So with that information, I went ahead and wrote that the sine is the opposite over the hypotenuse, which we know to be true. And then the cosine is the adjacent over the hypotenuse. We also know that the hypotenuse is never negative. So that negative sign for cosine v has to be for the adjacent side, okay? And since both of them are in quadrant 2, and I didn't want to kind of have so much writing in quadrant 2 with just one graph, because u and v are not the same angle, and so then I would just basically have one triangle on top of the other, and then it's a little bit hard to see which side goes with which side and which angle is the angle we're focusing on and all that good stuff. So the best way to do this, if they're both in quadrant 2, is just to draw 2 different graphs and then place both of those angles in quadrant 2. So I have one graph here for u, and then I have one graph here for v. And for u, I used this information that they gave me, and I put 3 as the opposite and 5 as the hypotenuse. In order for me to find this adjacent side, I did use the Pythagorean theorem. So hypotenuse squared minus side squared gave me this, and then eventually I get plus or minus 4. But since I am on this side of the x-axis, the x values are negative there in that quadrant. So we should be using the negative 4 for that square root, okay? And so I am using negative 4. So you already know that sine of u is 3/5 because you were given that. And cosine of u would be the adjacent side, negative 4, over the hypotenuse, which is where this negative 4/5 came from, okay? Now over here on the other triangle for v, we have that the adjacent side is negative 24 and the hypotenuse side is 25. Then in order for me to find this opposite side, I did the Pythagorean theorem. So the hypotenuse squared minus the side squared. I came up with these calculations, and the square root is plus or minus 7. And we choose positive 7 because in this quadrant, the y values here are positive. So then the sine is going to be the opposite, which is positive 7, over the hypotenuse, which is 25. Cosine of v was given to us as negative 24/25. So if they're wanting us to do sine of u plus v, I do have to do the sum formula for this angle or for this problem. And then it said sine of u is going to be 3/5, and then cosine of v is this one. Again, these were given, but these two were the ones we had to find. So cosine of u is the negative 4/5, and then sine of v is the 7/25. So I just typed the whole thing in my calculator, and it gave me negative 4/5, and that actually matched option D. Okay. So moving on to 29. I believe, let me share my screen again. 29 said for us to find the exact value of the given expression and using the sum or difference formula. So we do need to figure out a sum or a difference of 2 angles that are on that unit circle to get 285. Now, I came up with 2, but then I only continued working with one of them, okay? So let me show you what I did here. So I came up with 240 and 45 because both of those angles were on the unit circle. And if you add those two together, you do get 285. I also recognized that 330 minus 45 also gives you 285. So you could have done the sum or the difference. I just didn't do this one all the way through, okay? I only took the sum and went all the way with that one, okay? But if you do choose to do the difference, this would have a minus. And then of course, these numbers might be, or of course they're gonna be different. So these values will be different, but it should come out to the same thing here and then the same thing in the end, okay? So when I apply the formula, it said sine of the first angle, cosine of the second angle, plus sine of the second angle, cosine of the first angle. So I just plugged everybody in where they go in the formula, type this in the calculator. Each one of these I put in the calculator, or I grabbed them from the unit circle. I cannot recall, but these are the correct values, okay? Now, when I typed all of this in the calculator gave me this fraction here, okay? I didn't do anything but just type all of that in the calculator, okay? You may have even been able to type in all of this in the calculator and it would have given you this fraction, okay? However, I did notice that all the choices have a square root of 2 in the denominator. So in order for me to turn this into something that looks like one of the choices, I had to multiply by square root of 2 over square root of 2 so that I'm not changing this value, but I am changing the way it looks, right? So I took square root of 2 over 2 times that fraction, and in the numerator, I distributed the square root of 2. So I ended up with the square root of 12 and the square root of 4 inside this, but still both negative. And at the bottom, I just ended up with 4 times square root of 2. Then what I did is I typed square root of 12 in my calculator and it told me it was 2 square root of 3. I still kept it negative. And the square root of 4 in the calculator is 2. Again, still kept it negative. And the bottom does not simplify. Then I realized that 2 can be reduced from all 3 of these terms. So I factored out the 2 from the top terms. So this is just negative square root of 3 and just minus 1. And then that can reduce with the 4. So this factor 2 can reduce with the 4, leaving me with just a 2 in the denominator. So the fraction you end up with is over here, which is negative square root of 3 minus 1 over 2 square root of 2. And that does match option C, okay? So you do have that same choice there. Now let's go back. I think I saw it briefly, but I just want to look at it a little bit better. Is number 30. So number 30 was verify the given identity. And so I'm trying to explain it. I know I wrote a lot of steps on this one, but that's just because I didn't want to skip anything that I was doing in my brain to avoid confusion, okay? So the first thing I did was I just grabbed the left-hand side. So you'll notice whatever was on the left-hand side, that's exactly what I have here. And I took that side because that side looked more complicated than this side looked to me, okay? So this was the one that I used to start manipulating. So the first thing I did was I used the sum formula for the first cosine, and then I used the difference formula for the second cosine, and that's what I have here. Then I applied the difference of squares formula, and I got this thing times this thing, which is that thing squared, minus, right? And then this one times this one squared, okay? So, or this one times that one is that thing squared. Excuse me if I'm yawning, I had a long night, you know. I already messaged you guys about what was going on. Okay, so I went ahead and squared this term here. And so I ended up with cosine squared and x, and then cosine squared y. And I went ahead and squared each of these. So I have sine squared x and then sine squared y. Now from here, I noticed that the end result does have a cosine squared. So it does have this guy, cosine squared x, and it does have a sine squared y right there. So then I had a choice. I could have converted this one into 1 minus sine squared y, or I could convert this one into 1 minus cosine squared x. And I just went ahead and chose to do that one, although you could have a pretty similar solution if you had chose to convert this to 1 minus sine squared y, okay? But when I converted that, I put it in parentheses. So 1 minus cosine squared using the Pythagorean theorem, I just moved the sign over and then did all of the replacement here. Then I went ahead and I moved this, right? Because you have two terms. You have this term multiplied by that term, okay? So you do have the commutative property, which means you can swap them. So I did write the sine squared y in the front and this one in the back. I did that on purpose because I wanted you to see where this next line came from. It's a little bit confusing to tell you that I'm distributing a negative and distributing the sine squared y at the same time from this step, okay? But if I write it like this, then it's a little bit less confusing for you guys to see that I'm taking negative sine squared y and multiplying it by each of those terms in the parentheses. So the negative times that is going to give me this. The negative times the negative is going to give me a positive, that expression. And then I noticed that I had cosine squared x in this term, and then I had another cosine squared x in that term. So what I did was I rearranged my terms and I put these two together. Again, I just swapped them. I didn't do anything else differently. This term is now in the middle and this term is now on the end. Again, I did that so you could see where this next line comes from, because if I start trying to factor something from here and something from there, it might get a little confusing, okay? So to avoid that, I went ahead and just rewrote it, but swapping those two terms. Once I did that, you can tell that both of these have a cosine squared x, so we factored it out. And what's left is cosine squared y plus sine squared y. Well, the Pythagorean theorem tells us that that's just 1. So I end up with just cosine squared x minus sine squared y. And that is the right-hand side. And that's why I drew my little box, because I am completely finished with this problem, okay? On the final exam, there are no open-ended problems. The problems are more like, 31, and I think there was a couple of other ones like 25 and 24, where you just simplify it and then you would end up with something that is in the choices, okay? So we're gonna go on to number 31, and number 31, I believe, just says to simplify this expression, but let me go verify. So yes, it does. It says evaluate the following expression, and then just understand that x is not going to equal anything that would make these denominators 0, okay? Excuse me. So there, we're going to go ahead and take that. So let me stop sharing and I can get back to the problem. Okay, so we have this, and then what I did was I just kind of cross multiplied, right, so that I could get a common denominator. So I took this denominator and multiplied it in the numerator and the denominator. So I'm not changing the value of the fraction, just the way it looks. Then I took this denominator and multiplied it on top and bottom to the second fraction, okay? When I do that, I go ahead and take this 3 and distribute it to both of those two terms. And then this is a plus 3. If that was a minus, this would be a negative 3 that I have to distribute. But I'm distributing a positive 3 here, so I got these two terms. And then they do have the same denominator, so I just wrote that denominator once. Remember, it doesn't matter if the factor is here and then here, or the other way around, they're still the exact same thing, okay? So these 3's did cancel, and these are the same expression. I just have 3 here and 3 more, so I have 6 cosine of 2x. And then at the bottom, I use the cosine, the difference of squares formula, because these are the same, ones with the plus and ones with the minus. So I do end up with cosine squared of 2x minus 1. 1 squared is still 1, right? And then I had to get a little clever here, because I realized that in the answers, none of them had any fractions, okay? I could have also used Pythagorean theorem, but I chose to do it. I did use Pythagorean theorem, but I chose to do it in a specific way versus a different way, okay? And I'll explain that in a second. Let me just grab another color. So we do know that sine squared theta plus cosine squared theta equals 1. Well, I can subtract sine squared theta on both sides. And I would end up with cosine squared theta equal to 1 minus oh no, I'm doing this wrong. I want these two terms together. So I should be minusing cosine squared. So then I have sine squared theta equals 1 minus cosine squared theta. But notice that they're backwards from what I have here. So in order for me to change those signs, I'm going to have to divide everybody by a -1 or multiply everybody by a -1. What that does is it creates a negative sine squared theta, and then I have a -1 and a positive cosine squared theta. And then if I just rearrange these terms, I end up with that negative sine squared theta equals cosine squared theta minus 1. Okay, so I could have done all of this and then just replaced cosine squared any angle minus 1 with negative sine squared of that same angle. Okay, so I could have gone from here to here had I done all this stuff on the side. Okay, but I didn't. So what I did instead, and you'll notice it is probably a little bit less writing, is I converted the 1 into sine squared theta plus cosine squared theta. Theta in this case being the 2x, right? So there's my minus, and instead of the 1, I put sine squared 2x plus cosine squared 2x. Then I distributed that negative, and when I did, the cosine squared of 2x canceled, but I did still have the negative sine squared 2x, okay? Then what I did is I separated this fraction. So there is like an invisible 1 there, right? So I took the 6 over the -1 times the cosine over one of these signs, and then 1 over the other sign. So if I were to multiply all three of these together, I would get this numerator. And if I were to multiply all three of these things together, I would end up with this denominator. But I did separate it into the product of 3 different fractions. Now the first fraction, when I simplify that, I get -6. The second fraction, cosine of an angle over sine of an angle, is cotangent of that same angle. And then 1 over sine of an angle is cosecant of an angle. And then I just noticed that the option had this reversed, but remember they're multiplied together, so it doesn't matter what order you put them in. So it is equivalent to this as well, which matches option C. So let's go look at 32. So for 32, it says find all the solutions of the given interval. And let's see how we do that. So here we have this. Now, one thing we need to understand is that when we're solving non-linear equations, linear equations are different. You get x's on one side, numbers on the other side, and you divide, right? That's different. When you have problems that are non-linear, like squares, cubes, square roots, logarithms, trigonometric functions, anything that's non-linear, you have to get it equal to 0, factor it, and then set each factor equal to 0. There's no other way to solve that, okay? You've got to do it in that fashion. So the first thing I wanted to do was, I could have moved this over first, but I noticed that I had a double angle and a regular angle, and you cannot go any further with factoring and all that unless this is a regular angle as well. So I did use the double angle formula to break this up, and this expression right here does become this, 2 sine x cosine x, and then this thing is having a real hard time focusing. I'm realizing this. So let me see if I can push this button. Oh, no, that's not the button. Maybe that helps. I don't know what I just did, but maybe it'll help. Okay, so then I noticed that this 2 and this 2 would cancel, so I ended up with 3 sine x cosine x, still equal to this -3 cosine x. So then in order for me to get it equal to 0, I do need to add that over, which means this thing is going to be off. What is going on here? Oh, okay. It's not too far off, but I do have an error. So I do need to correct this. And then I'll make sure to send out a remind message to pay attention. Because when I move this over, what happens to it? I would have to add this over, right? So this would actually become a plus sign in there, okay? Then when I'm factoring out the common factors, which are 3 and cosine, I end up with sine x, but then this would be plus 1, okay? So when I set this factor equal to 0 and this factor equal to 0, that should now be a plus, okay? So then over here, I'm going to divide both sides by 3. But when I do that, the 3 goes away and 0 divided by 3 is still 0. If you look on the unit circle, where does the cosine, meaning the x value on the unit circle, where does that equal 0? The x value is 0 here and here. So that's at pi over 2 and 3 pi over 2. Now in this factor, I would have the minus 1 over, so this would be a negative 1. And for sine, that's the y value on the unit circle. The y value being negative 1 only happens down here, which is at 3 pi over 2. But you want to include all of the solutions. So we do have pi over 2 from this factor, and then we have 3 pi over 2 from both of the factors. So we do still end up with the same correct answer. I was worried a bit because I was like, wait a minute, if I got the wrong sign, then how is the answer still correct as the one in the back of the solutions? But now I see, because either whether it repeated the pi over 2 or whether it repeated the 3 pi over 2, this is still the overall solution. Okay, the next one, let's go see those directions. We are on number 33. So it says, use this figure to find the exact value of the trigonometric function, and that's secant of 2 theta. So they gave me this and they told me that this side was 1 unit and this side is 8 units. So on my paper, that's exactly what I did. I tried to recreate a right triangle in the same direction, put the 1 unit here, the 8 units down there. Now, in order for me to figure out the hypotenuse, I do have to do the one leg squared plus the other leg squared. So I did end up with the hypotenuse of square root of 65. So this does go up there, okay? Now, in order for me to evaluate secant of 2 theta, I did have to do some conversions, okay? So the first thing I did was write this as 1 over cosine of 2 theta. And then I used the double angle formula for cosine 2 theta, and I chose this one. There's 2 other options I could have chose, 3 options total. It doesn't matter which one you choose, you'll end up with the same answer, but this just happens to be the one that I chose. So I chose this equivalency for cosine of 2x. So then what that means is I'm basically doing 1 minus 2 and then the sine value squared. And how do you find the sine value? It's the opposite over the hypotenuse. So in this case, it would be 1 over the hypotenuse 6 squared root of 65. But that needs to get squared. So 1 squared is 1, and square root of 65 squared undoes the house, and so I just have 65. And then of course 2 times 1 over 65 is 2 65ths, right? 2 over 65. And then if I want to subtract those, I did do it in my calculator, but it would be 65 over 65 minus 2 over 65, which is where the 63 over 65 came from. And then of course, if you take that reciprocal, it's 65 over 3. Understand, I could have typed this whole thing in my calculator and it would have given me that answer, okay? I just chose, I don't know why. I guess while I was doing the problem, I was just doing it and not using my calculator all too much, unless I absolutely needed to. And so then I did it by hand. But you can do it in the calculator. And this does match option D, which is the correct solution. Okay. So now we have number 34. So number 34 says use the product to sum formulas to rewrite the product as a sum or a difference. Okay, so just side note, as you're going through these things and you see they're saying use this formula and that formula and whatnot, those are the things that I would be writing on my note sheet, right? I mean, there's some things that were on the note sheets for the tests that we didn't even particularly use. But this review is kind of really telling you what to look for, okay? So I would definitely put all the sum to product formulas. I would put all the sum and difference formulas. I would put, that unit circle. I would put all of those things on my note sheet just so that I have all that information. Having this example is great and all, but not necessarily if I change up on you the fact that this is cosine and that's sine. What if they're both cosine? And you didn't have the formulas down, all you had was your example on your note sheet. That doesn't help you with the new problem, okay? So make sure that if it talks about any kind of formulas, or if you had to use any kind of formulas, that you write down all the formulas in that category, okay? So like I had to use the Pythagorean identity a couple of times. I would write all three of the Pythagorean identities, the ones with tangent and cotangent, the ones with tangent and secant, and then cotangent and cosecant. I would have all of those down. I just used one that had to do with the sum rule. A few of them we did with the sum rule. I would have the sum formula and the difference formulas down on my paper. Okay, all of them, the sine sum, the cosine sum, the sine difference, and the cosine difference, okay? And then now they're asking me to use the product to sum formulas. There are 4 of them. One of them has cosine then sine. One of them has sine then cosine. One of them has 2 cosines. One of them has 2 sines, okay? It just depends on what you're multiplying together, which formula to use. So I would definitely write all of them. I just wanted to make that note just to make sure that you have everything that you need when you do need to take that final, okay? So please, please, please make sure you study correctly and make sure you get everything that you need. Now, I'm going to go ahead and do this problem. So this was a problem that was given to us. I did go look up the product. So this is the only part that's in the product rules, the product to sum rules. There's no number in front in those product to sum rules. So I just wrote the number in front and then just put a big bracket and then used the formula, okay? And so the formula was 1/2 times, and it's really like this. I should probably put a braces in here, okay? But it's really like 1/2 times both of these two terms, this sign and that sign, okay? And then what happens is that this 1/2 actually simplifies with that because it's on the outside, right? And then so is that. So these reduce and I just get 5. And then if I do add those together, I get this. And if I subtract those together, I get that. And the formula did have a minus in the middle, okay? Now I did notice that this was pretty close to one of the options, but the options didn't have a negative 9 pi over 10. So I used my even and odd identity. And for sine, when you have a negative on the inside, it actually changes this sign right there, okay? Because it comes out as a negative, but then that negative times that negative would end up becoming a positive sign of positive 9 pi over 10. And then this does match one of the choices and it matches choice D. Now for 35, I think this one is the sum to product, but let me verify. So now we're going sum to product. So again, make sure you have all 4 of those formulas on your paper, okay? So let's go see what that looks like. We have this. So I used the formula. This was the formula. All I did was add those together and subtract those together, and it actually matched one of the choices. I didn't need to do the even odd identity because it already matched one of the choices. 36 is an equation that you must solve, but they only want the solutions, not the general solutions, just the solutions between 0 and 2 pi. So here's the equation. And again, the strategy is that this is a 2x angle and that's just a regular angle. So I do need to convert this using one of the formulas. Excuse me, I did use the double angle formula and I got 2 sine x cosine x. Excuse me, I have a hiccups all of a sudden. Now I have to get this equal to 0. So I am going to minus sine x onto this side. These 2 terms both have a sine x in common. So when I factored it out, I ended up with 2 cosine x minus 1. This factor equal to 0 is here. This factor equal to 0 is there. And then for here, I just looked on the unit circle. Remember, sine is where the y value. So where's the y value on the unit circle equal to 0? That's here and here, which is 0 and pi. And then over here, I had to add 1 over, then I had to divide by 2. So I got cosine x equal to 1/2. And I thought, well, where is that? That's up here and then up here. And so it actually, no, when the x value is 1/2. So the x value is 1/2 there, and then the x value is 1/2 here. And so both of these, this one is pi over 3, and then that one's 5 pi over 3. So I ended up with 4 solutions. All 4 of these are in option A. Now, what does 37 look like? We're finally getting into unit 3. So it says use the law of sines to solve the triangle and then round your answer to 2 decimal places. So they gave me 2 angles. The third angle you can find using the 180 for the whole triangle. And then they gave me C, so I have to figure out what A and B are. So, oops, stop sharing. Sorry, that was my evaluation from an instructor that I was having to work on. Okay, there we go. So here we go. So for C, I did 180 minus 35 minus 60 minus 85 degrees. And then so that's how I found C, and all of them were the same, so that doesn't help me decide which one's the correct answer. But in order to find A, I had to do sine of big A over little a, and then sine of the big C over the little c, okay? And I had to use C because C is the only one where I have both bits of information. So I'm gonna have to use these 2 again to find B, okay? And that's down here, I set that one up. Sine of big B over little b, and then sine of big C over little c. Now in both of these, if you cross multiply and then divide by the leftover one, you get this fraction. Same thing here, if you cross over, multiply these, and then divide by the leftover one, you get this. And notice that I'm crossing, avoiding the letter. So I'm not cross multiplying this way because that's the letter. I'm cross multiplying this way and then dividing by the result, okay? Or the one that's left over. So I just typed this whole fractions in my calculator in degree mode, and it did pop out 5.76 for A and 8.69 for B, little b. And so that is matching option D. Now, number 38 asked us for the area of a triangle with these 3 bits of information. And so I do have 2 sides, and then the angle between them would be C, and I do have angle C. So I have enough to use one of those area formulas. As long as you have 2 sides and the angle in between, it's the same formula. It's just the product of the 2 sides times sine of the angle in between, and then half of that value, okay? So I typed that entire expression, 1/2 times 6 times 2 times sine of 102 degrees, all in the calculator in degree mode, and it gave me 5.9, and that does match option B. Now 39 also asked us to solve the triangle, okay? So in this one though, they only gave us 3 sides. So we had to find the 3 angles. Now you do need to use 2 of the 3 angles first in order to do the 180 thing with the whole triangle, okay? So you do have to find 3, and then you can use the triangle equals 180 degrees at the end for the third one. Now, this problem did tell me to use law of cosines, and so I did. So this is where this expression came from. Make sure that you have all of your law of cosine formulas, the ones for the angles and the ones for the sides, okay? That means 6 total formulas. Make sure you have all 6. Now I get cosine inverse of b squared plus c squared minus a squared over 2 times b times c. I typed the whole thing in the calculator in degree mode, and it popped out 36.02 degrees. Same thing here, finding capital B is a squared plus c squared minus b squared, and then over 2 times a times c. So the cosine inverse of all of that in degree mode does give you 55.41 degrees. Then if I wanted to find c, I could use another formula like this. I would get the same result, but I just went ahead and did 180 minus the a angle minus the b angle, and I got 88.57. And these three measures for those specific letters does match option E. Number 40 does ask you for the area of, no, it asks you to solve the triangle. So for this one, it does say use the law of cosines. So remember, you cannot use the law of sines unless you know one angle and then its opposite side. And I don't know this angle, I don't know that angle, and I don't know this guy's side. So I have no choice but to use the law of cosines. So the first thing I want to do is find this measurement, because if I do, then I could use law of sines afterward. But it looks like I stayed consistent and just found, just used the law of cosines twice. So here I use the formula, but for the side. So this is the formula for the side. It's b squared plus c squared minus 2 times b times c times cosine of capital A. I typed the whole thing, including the radical, in my calculator, and I got this value. Then to find b, I used the same formula that was up there. So cosine inverse of a squared plus c squared minus b squared over 2 times a times c. I typed the whole thing in the calculator, and I did not round this number. So when I used the calculator last, I had typed the square root of all of that, and this number was in my calculator unrounded, okay? The regular long version of this number. I left that in there, and when I went to type in this, I kept putting second answer here and second answer there. And so what that did is it put the long version of these numbers in these spots instead of just typing in 19.76. I did that on purpose because if I didn't, my decimals are coming out wrong, and I was not coming out with this exact angle here. But when I did leave it unrounded, it did come out to the correct angle, okay? And then once you have that, then I did the 180 minus capital A minus capital B, and that helped me figure out what capital C was. And these bits of information for these specific letters did fulfill option A. So all of that info was in option A. Now the last problem does ask us to calculate the area of a triangle, and all they do is give us the three sides. So I'm using the Heron's theorem, so make sure you have Heron's theorem. So you first find S, which is basically the perimeter all around the triangle. So you add up all the sides, it's like half the perimeter, and then divide it by 2. So I added all these up, divided by 2, and I got this. Then the area formula says you take that number, then you take it minus one of the sides, you take it minus the second side, and you take it minus the third side and multiply them all together. And then take the square root, right? I just typed the whole thing with the square root in my calculator, and it did pop out 17.2, which did match option E. Okay. So let's keep going. We got about 3 more pages to explain here, and then we are done. Okay. So let's go to share screen again. So this one is 42. And for 42, they have this plane situation. I didn't draw planes or anything like that, but I did try to draw a triangle as best as I could. It says to determine the distance between 2 aircraft. A tracking station continuously determines the distance to each aircraft and the angle between them. Determine the distance A between the planes when A, capital A, the angle A is 41 degrees, and little b is 34 miles, and little c is 19 miles. And then round your answer to 2 decimal places. So I am trying to find a, little a, and I do know big A, which means I should be able to use the law of sines or the law of cosines. But I think I had to use the law of cosines because I have this information. I don't have any information that's across from one another. So like I have little b, but not big B. I have little c, but not big C. And I have big A, but not little a. So I couldn't use law of sines, okay? So then I thought, well, let me go use law of cosines and see if I have all the information I need to find little a. And when I looked at the formula, it was b squared plus c squared minus 2 times b times c times cosine of capital A. And I had all of those values in it. So I just plugged them in, and then I typed the whole thing with the radical and everything in the calculator, and it gave me 23.28. Just make sure you're in degree mode because you are typing in degrees in there. Okay. And that does match option C. So I was good. That was correct. Now option 40, or I'm sorry, problem 43 asks you to find the unit vector in the same direction as this W vector. Okay. So in order for us to do that, we basically have to take that W vector and then divide it by its magnitude. And what you're doing is you're basically shrinking the vector so that it's only 1 unit long. And that is the definition of a unit vector. So we did the computations to find the magnitude. It's the first component squared plus the second component squared, and then the square root of that result. And so when I typed square root of 52 in my calculator, I got 2 square root of 13. I did put each of these two components over 2 square root of 13. And then I typed each of these in my calculator and it did reduce them, or you can reduce that by 2 and reduce that by 2 by hand and you still get the same values. If you did use the calculator to reduce that, it will pop out this. And if you use the calculator to reduce this one, it will rationalize it for you automatically. If you reduced it by hand, you can type that in the calculator and it will rationalize it. And then type this in the calculator and it will rationalize it. Okay. Your calculator will always automatically rationalize denominators. Okay. So if you notice none of the answers have square roots in the bottom, you probably best bet is just to plug them in the calculator and you'll get the two expressions without the square roots in the bottom. Okay. Number 44 was to find the work, to find the force when the work was 100 pounds and the angle was 11 degrees. And so I created the triangle. The triangle was not there for me. If I share my screen with you real quick for number 44, you'll see that it doesn't give me a triangle. All it does is say you have a force F that is required to pull an object weighing W pounds up a ramp inclined at some angle from the horizontal, okay? And so this is the horizontal. This is the horizontal and it's 11 degrees up from the horizontal. So this is the incline. You do have some weight that's pushing down on this. And they want to know what this side is, which would be the force, okay? So I do see that we're talking about the opposite side and the hypotenuse side, and that is sine, right? Sine of your angle is going to be the opposite side over the hypotenuse side. So then I do know what theta is, it's 11 degrees, and I do know what W is, it's 100. So I multiplied both sides by 100, and I got that F would be 100 sine of 11 degrees. Type that in my calculator in degree mode, and I did get 19.1, okay? And that does match option C, so we are good there. Okay, so then now we're gonna go to number 45. Number 45 just gave us U as -7,1, and it gave us V, which was 4, -5. So I went ahead and did the dot product, which means multiply the first components together, multiply the second components together, and then just add in the middle. So I did it by hand. I could have also typed the whole thing in my calculator and got -33, which does match C, option C, okay? For number 46, it gave me the two vectors, and then it asked me to find the angle between these two vectors, okay? So for this problem, I did use the formula. So the formula here was cosine inverse of U dot product V over the magnitude of U times the magnitude of V, okay? So I did just plug everything in. I plugged in U, plugged in V, did the magnitude of U, did the magnitude of V, ended up with these values, and I just left them like that and typed this whole thing in my calculator in degree mode so that I could get degrees answers. And I got 18.43 degrees, okay? For number 47, we have, it asks, this one is interesting. So let me go to share the thing so I can explain this, because we did cover this, but it seems like it was like just glossed over, I feel like, okay? And so I need to mention this a little bit more. So it does talk about to determine whether U and V are orthogonal, parallel, or neither, okay? Now orthogonal is easy to find because if you do the dot product and you get 0, then they're orthogonal. But in order for you to figure out if they're parallel, you're basically trying to figure out if one of these is a multiple of the other, okay? Meaning, can I multiply U by something to make it look like V? Or could I multiply V by something to make it look like U, okay? If you can do that, then they are parallel. And if you can't do that and their dot product is not equal to 0, then it is neither, okay? And so I'll go share my, or show my paper. So what I did is I took the dot product first. So I took one times the other, and I figured out that it was negative 27, okay? Or no, it was negative 64 over 3 minus 27, which is negative 145 over 3. Now that's not 0. So that means that they are not orthogonal. However, I did notice in my calculator what I did, and I'll show you on my calculator, is I took this one because this one's bigger. To me, that one's bigger. This is not my calculator. I took the bigger number, which is 16, and then I divided it by negative 4 over 3, okay? And it told me it was a factor of negative 12. So what that tells me is that if I multiply this number by negative 12, I will get 16. Now, the only way that these two are parallel to each other is if I also multiply this component by negative 12 and I get negative 18. So I did negative 12 times 3 over 2, and I did get negative 18. So what that tells me is that negative 12 times U is equal to V, which means that U and V are actually parallel, okay? And then I just did the computations on the side just so that you could see that one times the other is one term, and then the other component times negative 12 is the second term, okay? So in this case, we do get that they are parallel. Now, how would they not be parallel? If you do this division and you got negative 12, but then when you tried to multiply the second component by negative 12 and you didn't get this other second component, then that's when you would say, no, they're not parallel either, okay? And then in that case, if they're not parallel and they're not orthogonal, you would select neither. So let's go to number 48, what has to do with projection, okay? So they're asking us to find the projection of U onto V. So make sure you do have that formula. It is U times V over the magnitude of V squared times V itself. So you use V like 3 times and only use U once, okay? So I did the dot product there. I did the magnitude of V at the bottom. It did get 29 under the radical, but the square and the square root are going to undo each other. So that's why you ended up with just the 29. And then here we do have the vector 2, negative 5. So this reduced to 10 over 29. And then I just distributed in the 10 over 29 and ended up with these results. Okay. For 49, it had a little bit of different instructions. Okay. So for 49, it said find the projection of U onto V. Then write U as the sum of 2 orthogonal vectors one of which is the projection, okay? So in order to find that second one, you basically take U minus the projection and you'll figure out what that second one should be, okay? So I did that here. I found the projection first. I did the dot product again using V 3 times. I ended up with this, and then this turned out to be 0, and 0 over 37 is just 0. So when I distribute that 0, I actually get 0, 0 as my projection, okay? And if I want to find the second one, so you're looking for, this is like, we call this W1. And what you need to have is you need to have U equal to W1 plus W2. So if I want to find W2, all I'm doing is taking away W1 from both sides. And then that tells me that U minus W1 would give me W2. And so that's exactly what I'm doing to figure out what that second vector is going to be, okay? Because I have found one vector that gives me the sum to give me U, but I don't know what the second one is, okay? So I took the U minus that projection. So I took U, which was 30, 5, minus the 0, 0. 30 minus 0 is 30, 5 minus 0 is 5. So you do end up with, it coincidentally is the same thing as U, right? Because we got 0, 0. So that does match option B. Now, had this not been 0, these numbers would have been different. And then when I did the subtraction, I would have gotten something that looks different than the original U, okay? It only looks the same as the original U because of the projection was 0, the 0, 0 vector, okay? So that option B had both of those vectors in there, the 0, 0 and the 30, 5. Now 50, again, this is all stuff that looks a little bit similar, right? And some of these problems are the exact same problems as the ones that were on the test, and some of them are very, very, very similar. Okay. So if you're working on your test corrections and you haven't turned those in yet, these would be pretty good problems to look at for at least some of the problems that were on that test. Okay. So we do have a complex number. It is in quadrant 3 here. Okay, and so then I'm going to go over to my paper so you can see how I did that work. So the point they gave me was at -5 for x and -5 for y, which means my complex number is -5 minus 5i. Now, in order for me to find the radius, basically you're doing the x component and then plus the y component squared, right? So when I did this computation, I got the square root of 50, which reduced to 5 square root of 2. Now, in order for me to find the reference angle, you do tan inverse of B over A. I know you can't tell because they're both -5, but it is B over A, the Y value over the X value, right? Always when you do tan inverse should be the Y value over the X value. Now, when I do that in my calculator, I get 45 degrees. Or in radians, if I have it in radian mode, I get pi over 4 radians. However, we're talking here, this is 45 degrees, okay? But that's not where my point is. My point is over here, okay? And if you notice, this angle is the same thing as this angle. However, I have traveled all the way around that unit circle from 0 all the way down to this. And if I know that this measurement is 45 degrees, and I know from one end of the x-axis to the other end of the x-axis is 180 degrees, I just need to add those two together, okay? So I didn't do it in degree form because I noticed that all the options were in radians. So I took instead of 180 degrees, I took pi, and then I added the pi over 4 reference angle. And that gave me 5 pi over 4. And 5 pi over 4 is in quadrant 3, just like my point is in quadrant 3. So this is the correct angle that I should be using, okay? Now, then my complex number is going to be the radius times cosine of that angle plus I times sine of that angle, okay? And that actually matched option E. Now, the last one is, or not the last one, but the next one is they wanted me to perform the product of these two complex numbers in their trig forms. So there is some coefficients in here. You can't see them, but they always have a radius, right? Or a modulus. And it's 1 for that one, and then it's 1 for this one. So that's where this one and this one came from. You have to take the moduluses or the radiuses and multiply them together. And then if I'm multiplying, you actually add the two cosine angles together, add the two sine angles together. And so I end up with just 1 times cosine of 410 degrees plus I sine of 410 degrees. However, that wasn't in my options, so I found the equivalent angle that's in that same position, but that's not over 360 degrees. So all I did was subtract 360 degrees, because 410 would mean you're going around 360 and then a bit more, right? And how much is that bit more if I just want to know the same position, but without having to go all the way around first, okay? So I subtracted 360 degrees and got here, subtracted 360 degrees, and I got 50. And that did match option E. Now, number 52 asks us to do a division of two complex numbers. And so, of course, you do divide the coefficients or the radiuses or moduluses in the front. But then because it's division, you actually take the top angle minus the bottom angle. So when I did that, I got negative 30 degrees, but I noticed none of the options had negative 30 degrees. So what I did instead was I added 360 degrees because that means I went in this direction, 30 degrees. But I don't want to do that. I want to go around in the positive angle direction and see where I landed to get there. So I added 360 degrees, and it turns out you have to go around 330 degrees to be just 30 degrees shy of 360, right? And so that's where that angle came from. And then this did match option A. Okay, so number 53 is asking us to raise a complex number to a power, okay? And so I am using the de Moivre's rule, which means I'm going to get this radius or modulus with that exponent, and then cosine of this angle times that exponent, plus I sine of this angle times that exponent. So what I ended up with was this really large number times cosine of 1500 theta plus I sine of 1500 theta. And then what I did is I subtracted 360 from this until it turned into 60 degrees. And I subtracted 360 from this until it turned into 60 degrees. Then I looked on my unit circle and I got 1/2. I got square root of 3/2. Then I distributed that large number, and then that matched option C. However, I have this middle step scribbled out because I noticed if I just typed this in my calculator, this number times this, I got this fraction. And then when I multiplied this number times, not the I know the I is going to be sitting on the side. You can't type I in the calculator. But if I just put the I on the side and I multiply this number times sine of 1500 degrees in the calculator, it did give me this fraction, okay? So I just crossed that out because that was not necessary to do, but I did do it, okay? I did it the first time I was doing it, and then I looked back later and I was like, oh, I didn't need to do all that, but it never hurts to do extra. It's when you don't do enough that there's an issue, right? Okay, so the last problem is to find the fourth roots of a complex number. So the fourth roots of this complex number. Now, in order for me to figure that out, excuse me, I first have to, what's going on? I'm yawning, I'm sneezing, I'm hiccuping. Man, today's been something else. Okay, so here's my complex number. I went ahead and graphed it, right? This is a negative 1/2 x value and a positive square root of 3/2 y value. Now I could have looked on my unit circle for this, and I just didn't think to do that. But now that I'm looking at it again, it's always good to look at it with fresh eyes, right? You're trying to find the value with the point right here. And if you notice on the unit circle, the angle that has these coordinates is 120 degrees. And so you don't have to do all of this stuff to find that 120 degrees. You can just look at the unit circle, okay? I didn't do that. I found the radius the hard way. Well, you still have to find the radius, I guess. So I found the radius by doing this A value squared plus this B value squared. And I typed the whole thing in the calculator and it gave me 1. And then the tan inverse is the B value over the A value. And the calculator told me negative 60 degrees. So I know negative 60 degrees is here, but I'm trying to be over there, and notice that it's just a straight line. So I just added pi or 180 degrees to that number, and that was how I got 120 degrees. But you'll still have to do this to get the radius, but you could have looked at the unit circle just to find that point to get that angle. You didn't have to do the tan inverse and then add 180 and all of that, okay? Now, once I have this info, I know the radius, I know the angle, and I know how many roots I'm taking. I'm going to apply the formula. So the formula says the 4th root of the r, which is there. Then it says to take your angle plus 360 degrees times 0 over 4. And then this should have been the same thing in this parentheses, but I just used this to figure out what the angle was and then wrote that number there, okay? Make sure you follow your order of operations. Do not add these two together and then multiply. That is not the order of operations. You are supposed to always multiply before you add, okay? So this is 0, and 0 plus 120 is 120. And then that result gets divided by 4, and you get the 30 degrees. I noticed some people were forgetting their order of operations on the test. So make sure that you remember to multiply before you add. Then for the next one, I am doing 120 plus 360 times 1 over 4. And when I type all of that inside the parentheses in my calculator, I did get 120 degrees. And the 4th root of 1 is still just a 1, okay? Here it's 120 degrees plus 360 times 3 over 4. And after computing that fraction, I got 210 degrees. Finally, the last one, oh, this is a 2, I'm sorry. And then on the last one, it's 120 degrees plus 360 times 3 over 4. And when I type all of that in the calculator, I got 300 degrees. Now, all of these 4th roots are just 1. So notice that there's no coefficient because when I distribute the 1, it just stays cosine and sine, right? But you will have all 4 of these in option B, okay? And I could have stopped there because honestly, there was only one option B that had the 30 degrees at the top, okay? So I could have stopped there, but I just wanted to show you where the other 3 came from, okay? But that is it. That's the end of the final review.